In this video I'm going to attempt to derive the expression for the energy stored in a capacitor. And if you don't want to follow the derivation, then the formula is just given in your data booklet as being E for energy equals 1/2 times capacitance C times the square of the potential difference. That's given in your data booklet. Okay, but let's start off for the derivation with the definition of capacitance. So capacitance is charge per unit potential difference. Let's just rearrange this. So I get potential difference is equal to charge divided by voltage. Sorry, capacitance. So comparing this with the equation of a straight line, if this was my y and Q was my x, then if I was to plot potential difference against charge, I would get a straight line through the origin whose gradient is equal to 1 upon the capacitance. Now, also, if you remember the definition of potential difference is the work done per unit charge, moving charges across an electric field. So, in other words, the work done, or the energy, is the charge times the potential difference. Now, if we look at this graph here, I have a potential against charge. The quantity that defines, or the quantity of area under this graph, is basically the potential times the charge, is basically the energy stored in that capacitor for any charge Q. So the physical meaning of the area under this voltage charge graph for a capacitor, parallel plate capacitor, is the energy stored in that capacitor. Now we can either use calculus here, or we can maybe use some simple geometry arguments. The area under this graph is a triangle, so the area, the energy, equals the area, which is 1/2 times the base, which is the charge, times by the potential, which is V. Now we just want to rearrange this in terms of capacitance. So using the definition of capacitance, I'm going to substitute Q with V times C from the definition up here. So you get that the energy equals 1/2 times V times C times V, which is the same as energy equals 1/2 times the capacitance C times V squared. So the formula is easy to recall because it's in the data booklet, but if you're given a voltage charge graph, remember that the area under the graph is the energy stored and the gradient is 1 upon the capacitance.